Okay. How are there local maxima and minima, and where does the ends go to? Okay. And so what does that mean? Let's take a look at a few graphs. So here's what you're used to seeing, right? In your basic math, you've seen the linear function. You know that this is your y-intercept, right? And you know that this from this right here, this is change of y over change of x is your slope, right? And the slope will stay the same in a linear function throughout the rest of that function, right? It is part of a polynomial. It's the simplest of the polynomial functions. Here we have a cubed function. Notice it looks a little bit different than what we saw earlier, right? Okay, that's the standard f of x equals x cubed. And so notice we have some variations here. However, so here are some things. It's symmetric to the y-axis, okay? Notice you have a local maximum and a local minimum. Notice it's not the complete maximum and complete minimum, right? The complete maximum here is it goes to infinity, and the complete minimum here goes to negative infinity. But these are called a local max and a local min. What else is there? Oh, there's a few x-intercepts, right? And again, I would graph this. If it's a quadratic function, you can find it through quadratic equation or whatever, but this you can graph. And this is kind of easy to see. There's one at 0, there's one at negative 1/2, and at positive 1/2. What else did they say here? Oops. What happens? Yeah, that was it. Okay, so we covered all the sort of basic parts for the graph. And again, it can get even more complicated, right? Here's another cubed function, okay? It looks kind of wonky. You can, this is x to the 5th, okay? And so notice it's to the 5th and has 1, 2, 3, 4 local minimum and maximums. Okay, I think it can have, yeah, it's always like to the, whatever that top value is, -1. Ooh, I can't remember. I think that's what it is. Here's an x squared function, which is just a parabola. Here's an x to the 4th function. Okay, so notice for your x squared, which is even, x to the 4th, which is also even, the ends go in the same direction, okay? And for our odd functions like the 5th, the 3rd, and the 4th, the ends go in opposite directions. Opposite, one goes positive, one goes negative. Oops, sorry, I keep going backwards. One goes positive and goes negative, and same thing for this one, right? So for odd functions, 1, 5, 3, 7, 9, the ends go in opposite directions. For even functions, 2, 4, 6, 8, 10, they go in the same direction, okay? So see, same direction, right? Oh, I think it just says that. For odd functions, here are some characteristics for odd functions. The graph is symmetric about the origin for an odd polynomial. 1, 3, 5, 7, 9 starts negative and ends positive, or vice versa. And the polynomial of the degree n crosses the axis at least once and at most n times. Okay, so not n-1. So at least once, so to the 5th power can cross up to 5 times, right? Even polynomials, it's symmetric about the y-axis, which is the y-axis. It starts negative and ends negative, or starts positive and ends positive. It crosses the x-axis at most n times, or it might not cross it at all, right? You might not have an x-intercept. All right, so these are characteristics of polynomials. They're continuous. They do not have sharp corners. You may have an x-intercept or you may not, right? So who had the imaginary one? You guys did. It does not, it's still a polynomial, it's still quadratic, it just doesn't cross the x-axis. That's what that means when you get an imaginary number. Ooh, are you guys hot? I'm a little bit warm. The AC turns off after so much time. It really does. The internet stops working, the AC stops working. It's so great. We're not going to do quadratic regression. Do not learn it. Do not go over it. Don't read about it. We're not going to do it. All right, so rational functions. So we're going to see nothing but rational functions in calculus. Okay, that's the reason why I wanted to kind of go over this. Polynomial and rational functions. You might see, like a polynomial, and it's all rational and it's all jumbled together and you have to find the derivative of it. Okay, so a rational function just means there is a function on the top and there is a function on the bottom. It can be this simple, it could be simpler, it could be more complicated. Okay, it just means there's two functions as the numerator and the denominator. Okay, and the denominator, this guy, cannot equal 0, obviously, right? So the trick is finding the domain and range of something like this. And this idea of a vertical asymptote. So I really don't have time to teach how to find the vertical asymptote or like for you to practice doing it. But the whole idea is you just set the denominator equal to 0, and this gives you your vertical asymptote every single time. Okay? Every time. If you want to know where that vertical asymptote is. And right, so if you set this equal to 0, x is equal to 2, and that's what that is right here. And worst case scenario, just graph it on Desmos. I don't remember what she said. I'll try to post the video, but I don't remember what I said, right? And just graph it, and you'll see where that vertical asymptote is. And that's just important because what if you get a solution that is along that vertical asymptote, right? Then you really don't have a solution. You did something wrong, okay? You also have horizontal asymptotes. This is a little bit trickier. There are some characteristics for finding the horizontal asymptote, but typically it has to do with the x's in the numerator and the denominator. And I think I have a chart for it. I'll try to post it. It's a good little chart. Nothing I'm going to take the time to teach you today. Okay? So that's it. I think that's it. I just wanted to show you rational functions, kind of what they look like, kind of know that you have to have a vertical and you always typically have a vertical asymptote with a rational function, okay? And typically your horizontal asymptote is like 0 or 1. It's the ratio of the coefficients of those leading things, but it's not terribly important. Okay, last bit, and then you guys get to answer your question, and then go home. All right, so exponential functions. Well, I just want to explain next week, and then you guys can go home. This is basically what I asked you to graph 2 to the x power. Okay, and so this is the idea. It's an exponential function, right? Typically, you have f of x equals, x to the b, right? Yeah. And so now it's flipped. And this function leads us to what's called e to the x, which leads us to what are called logarithms and natural logarithms. Really, e to the x leads us to natural logarithms. And they're really a lot of things in nature behave that way. You can predict behavior using e and the natural log, which is the ln of x. Okay? A lot of things in chemistry, biology follow that sort of exponential kind of behavior. All right, so an exponential function, so you have the constant b to the x power. The domain of f is all real values, right? There are no values that are not included in this, while the range is only positive values. Okay, you cannot have a negative set of values. We're not going to do the riddle, and we're not going to do this. All right, so here's our function 2 to the x. All right, so here if you were to use a table, okay, to graph the exponential function above, note that x is a real number and can be replaced with numbers such as square root of 2 as well as any other rational number like pi, all right? But we're going to use integer values, right? So here they have the graph, and that's your actual graph, okay? And that's all you have to show me. And notice what's happening here. If we use values like -4, -3, -2, 1. So negative values, notice what value we're approaching as we continue for negative increase the negative values. What value, why are we approaching? What is that getting close to? Really, really close to. As you increase in the value of negative numbers, what is this getting closer and closer to? This is y, right?
Oh, 0.
Yes, that's what I was looking for. For any exponential function, okay, 2 to the x, 3 to the x, it does not matter. It all looks like that, okay? As you increase and put in larger negative values in your exponent, it gets closer and closer to 0, but never reaches it. You'll never reach 0, okay? And as you increase in your positive values, you'll just reach infinity, okay? So, that being said, basic properties of an exponential graph, right? All graphs will pass through 0 and 1. That's your y-intercept. They are all continuous. There should not be a hole. The x-axis is always the horizontal asymptote. If b is greater than 1, then b increases as x increases. If b is less than 1 but greater than 0, the function will decrease as x increases. Okay, so just some basic ideas of a graph. And then one last thing here, 2 to the minus x really looks like that, right? Anytime you have an exponential, a negative exponent, right? It turns around and it looks like this. So if you were to have, I don't know, x to the minus 2, it's 1 over x squared, right? And so in this case, 2 to the minus x, it's 1 over 2 to the x. And so notice it goes the opposite direction, right? So your first function was 2 to the x. This is 1 over 2 to the x, and it's going in the opposite direction, or 2 to the minus x. Okay, so if you have graphed it, great. Just write it down and get ready to turn that in. But let me just explain how next week is going to go, since we all decided, is everybody really okay with it being a hybrid class? Yes? Does anybody think that they will? Okay, so what I did is I sent you all an email. If you need me more, I gave you all my cell phone number. Because if you email me and I don't get back to you, it's because I probably didn't get the email. And I just haven't got it yet. But if you're like absolutely need my help, just text me. And I will get back to you faster than if you email me. All right, so next week is online. You're going to cover 4 sections. I made the classwork due Wednesday just so you don't leave it all to the end. So like it just allows you to read through it, and then the homework is still due Sunday again.
There's a problem with the homework this week.
Is it?
It's closed.
Oh, when did you open it? Hold on, let me just check. Oh, so dumb. Okay, hold on. Let me fix it.
Because we did it here, right?
No, there's homework, so that's this class. So I always think that I fix these things, and sometimes
There's homework for next week.
This week too.
Okay.
Yeah, there's homework every week. Your homework is always a multiple choice. I run almost all my classes the same way. Homework's always due Sunday. It's always multiple choice. I think I might have given you a timer on this just for you to, what's today's date? The 14th. It is due Sunday. Okay. So I fixed it. I always think I change it, and then somebody says I didn't. So anyways, you can hand me your classwork. I'll just give you the points for it. You do have homework that is due by Sunday. Next week, because we're not going to be in class, you have a discussion to do, all right? 300 words. You just write about the difference between calculus and algebra. Provide your references. Please do not copy and paste the article. I do not care if your English is not that good. I would rather that you would write it than me just reading another article, okay? Just do your best, and I'm pretty fair. I just want to see that you're trying. Yes.
So every homework is due on Sunday. Do we have a post, a class post and then homework, or just straight homework?
So when we're in class, just the homework. Okay. And what you turn in for in class. Okay. When we're online, you have a class assignment, you have a discussion, and you have a homework.
What does discussion do?
So I have it due Wednesday, but what do you guys want? I can be fair.
Let's do Friday that way.
Okay. I will have. So the only thing about having it due Friday is that if you don't post till Friday, nobody could respond to you. So what I've been doing is like post it Wednesday. I don't care if it's junk. Yeah, your first post.
That works.
That's fine.
Okay, and then you respond until Friday.
Okay,
yeah, that works.
Okay. And then again, homework is due. So just really quick for the classwork next week, it's mostly just it's not really problems. Okay.
Definition.
Yeah, definition. What are the 8 properties of a limit? What does it mean to be indeterminate? So there's one. So every lecture has a handful of questions. And if you don't have the time to listen to all of it, because they're about 30 minutes apiece, just go through the PowerPoint.
Okay.
I think the PowerPoint is there available, is there. I think there is. If it's not, just email me and let me know. Yeah, no, it's there. And that's it. So I will see you week 3, which is January 28th. Okay?
January 6th, right?
January. Okay, you're joking. I don't always get that.
So do we need any exercises on the book? Does this book belong to the school?
Not right now. I just.
Picture of it, you know what I mean?
Yeah. If you right now, there's nothing.
Okay.
Are we gonna need our books so I can order from Amazon, or?
Okay, so I like having books because I think they're a good reference when you're doing a problem.
Yeah.
You don't. If you could just check them out, you don't have to buy them.
Yeah.
Okay. Well, that's why I'm.
Yeah, that's fine.
If not, then I don't have a problem. If I'm gonna use it for firewood.
Yeah, I mean, yeah. My daughter tells me because so I have my master's in physics. I teach math, so obviously I like math, right? And that's just I do like it, right?
You like giving tips. You don't like math.
My daughter, on the other hand, total opposite of me, hates it, and so she tells me she's in. Oh, I'm recording this. Sorry.